Welcome back to my video series working through the SonicPy tutorial. In this video, section 8, data structures. Data structures. A very useful tool in a programmer's toolkit is a data structure. Sometimes you may wish to represent and use more than one thing. For example, you may find it useful to have a series of notes to play one after another. Programming languages have data structures to allow you to do exactly this. There are many exciting and exotic structures available to programmers, and people are always inventing new ones. However, for now we only really need to consider a very simple data structure, the list. Let's look at it in more detail. We'll cover its basic form and then also how lists can be used to represent scales and chords. Section 8.1. Lists. In this section, we'll take a look at a data structure which is very useful. The list. We met it briefly before in the section on randomization when we randomly chose from a list of notes to play. Play, choose, 50, 52, 62, 55, 62. In this section, we'll explore using lists to also represent chords and scales. First, let's recap how we might play a chord. Remember that if we don't use sleep, sounds happen all at the same time. Let's look at that. Play 52. Play 55, play 59. Let's play that. Hey, a chord. Right. Playing a list. One option is to place all the notes in a list. So like 52, 55, 59, end bracket. Our friendly play function is smart enough to know how to play a list of notes. Try it. So we'll play that and run. We'll just run. Oh, that's already nicer to read. Playing a list of notes doesn't stop you from using any of the parameters as normal. Well, let's try that with amp : 0.3, comma, amp : 0.3. Run that. So there it is, quieter. Of course, you can also use the traditional note names instead of MIDI numbers. So we can say :E3, G3, B3. Run that. Take away the amplitude opt. And there's that. Now those of you lucky enough to have studied some music theory might recognize that chord as E minor played in the third octave. E, G, B, sure enough. Accessing a list. Another very useful feature of the list is the ability to get information out of it. This may sound a bit strange, but it's no more complicated than someone asking you to turn a book to page 23. With a list, you'd say, what's the element at index 23? The only strange thing is that programming indexes usually start at 0, not 1. With list indexes, we don't count 1, 2, 3, instead we count 0, 1, 2, ... Let's look at this in a little more detail. Take a look at this list, 52, 55, 59. There's nothing especially scary about this. Now, what's the second element in that list? Yes, of course, it's 55. That was easy. Let's see if we can get the computer to answer it for us too. Put S, that thing, bracket 1. Run that. And it puts 55. So let's look at what happened. We put S, I'm pretty sure means put string, at index 1. So that's 0, 1. 55, 55. Okay, that looks a bit weird if you've never seen anything like it before. Trust me though, it's not too hard. There are 3 parts to the line above. The word put S, our list, 55, 52, 59, and our index 1. First we're saying put S because we want SonicPy to print the answer for us out in the log. Next we're giving it our list, and finally our index is asking for the second element. We need to surround our index with square brackets, and because counting starts at 0, the index for the second element is 1. Look at the picture there, indexes 0, 1, 2, and they line up there. Try running the code, put S 52, 55, 59, 1, and you'll see 55 pop up in the log. That was over here in the log. Change the index 1 to other indexes. Try longer lists and think about how you might use a list in your next code jam. For example, what musical structures might be represented as a series of numbers? So let's just check for index 0, 52, index 2, 59. Let's add some more numbers here, like 60, 61, 60, 62. And I think I lost my bracket. There we go. 0, 1, 2, 3, 4, 5. That should be 62. Index 5, run that, and we get 62. Yep, it works. Now, to answer his question about what musical structures might be represented as a series of numbers, we can go to the next section, Chords. Section 8.2, Chords. SonicPy has built-in support for chord names which will return lists. Try it for yourself. Play chord E3 minor. I already typed that out. Oh, put S. I want to play it. Now we're really getting somewhere. This looks a lot more pretty than the raw lists and is easier to read for other people. So what other chords does SonicPy support? Well, a lot. Try some of these. We could try chord, colon E3, comma, colon minor 7. Play that. Oh, I need to actually play it. E3 minor 7, E3 minor, already tried that one, but we'll do it again. E3 dim 7, 4 notes. E3 dom 7. Yep. Arpeggios. We can easily turn chords into arpeggios with the function play pattern. Okay, let's play pattern chord E3 M7. Okay, that's not so fun. It played it really slowly. Play pattern will play each note in the list separated with a call to sleep 1 between each call to play. We can use another function, play pattern timed, to specify our own timings and speed things up. So play pattern timed chord E3 M7, comma 0.25. We can even pass a list of times, which will treat it as a circle of times. So play pattern timed chord I3 minor 13. Wow. And then the list 0.25 comma 0.5. Run that. I made some error. Unexpected float literal. Oh, 0.5. I need comma 0.5. So it does the one duration of wait in the other one. This is equivalent to play 52, sleep 0.25, play 55, sleep 0.5, play 59, sleep 0.25, play 62, sleep 0.5, play 60, and so on. Which would you prefer to write? Yeah, hands down, I prefer this one. Although I will say that the second option gives you more flexibility, right? 8.3, scales. SonicPy has wide support for a wide range of scales. How about playing a C3 major scale? We could say play pattern timed scale colon C3 colon major comma 0.125 comma release 0.1. Listen to that. Huh, that's nice. How about all the notes in a pentatonic scale? Play pattern timed scale C3 major pentatonic, comma, num octaves 3. Okay, try that. That's nice. Random notes. Chords and scales are a great way of constraining a random choice to something meaningful. Have it play with this example, which picks random notes from the chord E3 minor. So use synth, TB303, loop, do, play, choose, chord, E3, minor, release 0.3, cut off R rand 60 120. Sleep 0.25 and end. We'll try that. And stop that. That's nice. Try switching in different chord names and cutoff ranges, okay? Let's try E3 major with cutoff 90 to 120. And let's try it with M13, which I think means minor 13. That's nice. Discovering chords and scales. To find out which scales and chords are supported by Sonic Pi, simply click the Lang button on the far left of this tutorial, then choose either chord or scale in the API list. In the information in the main panel, scroll down until you see a long list of chords or scales, depending on which you're looking at. Have fun and remember, there are no mistakes, only opportunities. Let's take a look at Lang. So scroll down until you see chord. There's chord. Is this it? Example. Sonic Pi supports a large range of chords. Notice the more exotic ones have to be surrounded by single quotes. That is a lot of chords. And let's look at scales. Hey, does it have a dictionary? I don't know. I'm looking for scales. LMPRS, scale. Scroll down, example, and there's all of the scales. That's a lot of scales. That's a lot of scales. Cool. I'm going to call it there for this video. Thanks for watching.